Alright, so finishing this out, we have to know how to find an exponential function knowing points that it goes through. So it's just substitution and then solving. Sometimes you're really lucky and you get a point that gives you one of your two variables right away. We are looking for A and B. So we need to know that our points are giving us x's and y's. And so we're going to substitute those in. And so when we substitute in, we have our y is 3 equals a and b, which we're trying to find, and our x is 0. Since we know b to the 0 is 1, we get to solve right away. B to the 0 is 1. 1 times a is a. So a is 3. We now know a is 3, so we can substitute a equals 3 into the equation. Before we plug in our next set of points, our x and our y. Substituting in, we have 81 equals 3b to the 4th power. So we divide both sides by 3, and then we take the 4th root. b is the 4th root of 27, which means our exponential function y equals 3 times the 4th root of 27 to the x power. Now, if we want to be fancy, we know 27 is 3 cubed, and we know that the square root of 4 is the 1/4 power. Using our powers to powers rule, we can change the 4th root of 27 into 3 to the 3/4, so that we have 3 to the 3/4 x. Either one of those is correct. Just different forms of the same thing. Now, the property of inequalities is just like the property of equalities. You have to have your b is bigger than 1, but once you do, as long as the bases match, then you can set the exponents. This time it's not equal to, it's whatever the inequality is. Greater thans become greater thans, and less thans become less thans. So after that, it's just solving. So again, we have to make the bases match. So we're going to start by changing the 64 into 4 cubed. We're going to convert our fraction into a negative exponent so that our bases match, and we can set the exponents equal to each other, except they're not equal this time. They are greater than. So 1 minus 2x is greater than negative 3. So negative 2x is greater than negative 4. And dividing both sides by negative 2, x is less than positive 2. Remembering that whenever we multiply or divide both sides by a negative number, we flip the inequality around. So we have done inequalities. You do need to remember your inequality work. So let's take a little bit of time here just to look at polynomials. When we were doing polynomials, we first learned how to factor things. So we can factor this into x plus 3 times x minus 1. We're looking at where is this greater than 0. So if we make a chart, our positive 1 and our negative 3 make this function 0. Which means in each one of those sections, our function is either going to be positive or negative. So if we look at one part of the function, x plus 3, over here on this side of negative 3, at negative 4, x plus 3 is going to be negative. If we look at it x plus 3 in between the negative 3 and 1. We can pick any point, but I'm going to pick the 0. And we have a positive. And if we pick a point over here like 2, we also have a positive. If we look at the other factor, x minus 1, when we plug in negative 4, we have negative 5. When we plug in 0, we have negative 1. And when we plug in 2, we have positive 1. So now when you look at the two things together, the function x plus 3 times x minus 1, you're multiplying. So a negative times a negative, doesn't matter what it is always a positive. A positive times a negative is always a negative. And a positive times a positive is always a positive. We are looking for greater than. Greater than 0 means positive. So we're looking for these two pieces of the puzzle. So x has to be less than negative 3, or x has to be greater than 1. Or an interval notation. Everything from negative infinity to negative 3 not inclusive. Union, everything from 1 to infinity. So if we change the greater than to less than, we could go through the same thing, make the same table. But instead, I'm going to say, hey, let's graph that. X equals negative b over 2a for our vertex. So negative 2 divided by 2 times 1. The x for the vertex is negative 1. Plugging that negative 1 in, f of negative 1 is negative 1 squared minus 2 minus 3, which is negative 4. So my vertex is at the point negative 1, negative 4. Going over 1, up 1, and over 1, up 3. Over 1, up 1, over 1, up 3. And there's my parabola. I am looking for where it is less than 0. So where are the y values less than 0? Oh, those are all the points between negative 3 and positive 1. You would have to find the x-intercepts to use this method, but we got them just straight from graphing, doing our pattern. So our x is between negative 3 and positive 1. Both methods really give you the same thing. And have a wonderful, wonderful weekend.